Exponent properties and Frayer models. Today you'll be making Frayer models using our exponent properties. Our first problem is a multiplication problem. To get started, I'm going to expand this so it's easier to work with. I'm going to change colors for the variables too. Let's see, I'll do the X's in orange and the Y's in green. And then back to times 4, and the X's in orange, and the Y's in green. By looking at it in expanded form, it's easy to see how many X's and Y's there are. I think next I'll go ahead and solve it. 6 times 4 is 24. And I can see there are 3 X's, so X to the 3rd power. And there's 4, 5, 6, 7 Y's. So there's my answer in simplest form. Because this is a multiplication problem, this is the product of a power. The shortcut is to keep the base and add the exponents. Some words to describe it. Thinking about the coefficients, that we have to multiply the coefficients and add the exponents. Okay, so I think we have all 4 parts of that Frayer model. Let's start this one in the same way by going to the expanded form. That might help us solve the problem. Okay, there's my numerator. And then divide it by a to the 2nd and b. Okay, when I have it in expanded form, then I can see a divided by a, that would cancel out, and the b's would cancel out. And then I would have to take care of the coefficients with division. So I'm going to go down here into simplest form next. And 40 divided by 5 is 8. And, oh, there was another a I could cross out. Okay, so I'm left with one a in the numerator and a b in the numerator. So my property rule, since this is a division problem, this is going to be in here. It's the quotient of powers, where we could have kept the base and subtracted the exponents. Okay, so I've written the quotient of power, keep the base, subtract the exponents. Words to describe up here, I might again go back to that idea of coefficients and to use division on the coefficients and use subtraction on the exponents. Okay, so I typed that up to make it a little neater. All right, I think this one is finished. Okay, let's go ahead with the same process. Let's expand and take a look and see what we have here. Okay, I've expanded my numerator. Now I'm expanding the denominator. And 4 O's. Okay, let's see if we can cancel anything out. M, N, and 2 O's. Okay, so let's go here to our answer. So this is interesting. We can see there's an M left in the denominator and 2 O's, so O to the 2nd power. And in the numerator, we have 3 N's left. Or we could write that N to the 3rd. Okay. So, Okay, property or rule, I guess we could say it's the quotient of powers, keep the base, subtract the exponents. Okay, I typed that to make it a little neater. Quotient of powers, keep the base, and subtract the exponents. But I wanted to point out that if we subtracted the exponents here, this would be 3 minus 4. And that would give you m to the negative 1. And then n to the, there would be 1 there, n to the third. And then o to the negative 2. So then notice in our answer, these negative exponents went down into the denominator. So in words to describe, I want to make a note of negative exponents become positive fractions, or you move them to the denominator. Okay. Okay, let's begin the same process. Let's expand it first and see what that looks like inside the parenthesis, and then we'll talk about what this other exponent of 2 means. Okay, so that's what inside the parentheses looks like. And then the 2 on the outside means there's 2 groups of that. So we have to repeat that exactly. Okay, so I wrote really big, didn't quite fit in the box, but that's okay. Now we can simplify. So let's do the coefficients first. So 4 is multiplication, because parentheses indicate multiplication. So 4 times 4 is 16. And then how many p's do we have? Here's 2 and 2 more, so p to the 4th. And then a q and a q, so q to the 2nd power. And let's see, 3 plus 3 is 6, so r to the 6th power would be our simplified form. So what rule is this? What property is happening here? This is power to a power. Okay, so as power to a power, keep the base and multiply the exponents. So some things to keep in mind here. This 2, we did 4 to the 2nd power, which was 16. And then we multiplied the exponents, which was p4. And then there's no exponent here or a 1 to get q2. And then 3 times 2 is 6. So that would have been the shortcut. But I really like expanding it because it makes it really easy and clear to see how many you have. Okay, so words to describe, I would say that parentheses means multiplication. And then again, just be careful with the coefficients. Okay, so there was a way to use Frayer models with exponent properties, and what I really like about the expanded form is it really makes it easy to see what the simplified form would be.